In this video, I want to talk about the distance formula. If you will play along, I would like you to just take any piece of paper, scrap piece of paper, your notebook, and draw the XY axes, so the Cartesian plane. On this Cartesian plane, I'm going to describe what I want you to do before I actually do it with you. I want you to put 2 points on your XY axes. They can be anywhere, really. Don't be nervous. I would suggest that they are not along a vertical line or a horizontal line. What I mean by that is I don't want your 2 points to have the same X value nor the same Y value. If you need to erase one, that's fine. So now you should have 2 points in the XY plane, and the next thing I want you to do is connect those 2 points. So you should have a little line segment between those 2 points. The next thing I want you to do, and I will do this with you to explain, we are going to make a triangle, a right triangle, whose hypotenuse is the line segment you just drew. So what we're going to do is we're going to take whatever your third point will be the third point of a right triangle, and that point will be directly across from your hypotenuse. I'll go ahead and show you what I'm doing. Now, when I do this, I don't want you, sometimes students feel like they have to do what the teacher does, and that's definitely not true. The reason I had each of you do that differently is because I've done this for years. Students will have completely different pictures, which is completely okay. Your picture does not need to look like what I'm about to do. And that is what is so great about the distance formula. It would work for any 2 points in the plane. So here I've drawn 2 points. Now I hope yours are not in the exact same place. Don't adjust yours, they're just fine. I'm going to connect these 2 points like I ask you to do. I'm going to label that D for distance, actually. And the next thing, I told you that we were going to make a right triangle. So my right triangle is going to use the points that would have the same X values as this point up here, and points that have the same Y value as this point, so that my right angle is across from that hypotenuse. You might have a triangle that looks like this. Totally fine. You might have a triangle in a completely different quadrant. Completely fine. If your D is a vertical or horizontal line, I would like you to redraw your picture. It's not necessarily, it isn't incorrect. It's just kind of so easy that we don't necessarily have to use a distance formula because you're just finding the change vertically or horizontally. That's why I'd kind of like you to have a diagonal there for your distance. All right. Now, you've heard of the distance formula, so let's see if we understand where this comes from. So for these points on this right triangle, this point up top, I'm going to call x2, comma y2. The point on the bottom, I'm going to call x1, y1. I have no particular reason for those names. 1 and 2 are simply subscripts, perhaps denoting the first point and the second point. I'd like you to label your triangle. You can label those points. It does not matter if one is higher than the other, but go ahead and name one of them x1, y1, and one of them x2, y2, like I have done. Your picture, again, does not need to look the exact same. Just make sure you're naming the points you started with, not the point that is on the right angle. Once you've named those, let's talk about the distance, this vertical distance right here. Yours might be in a different location, but if you think about it, this point, if it has the exact same, I did need to walk you through this. Let's go ahead and talk about this point, and then we'll go back to that distance. This point on the right triangle is going to have the same X value as one of your points. In my picture, it's beneath this green point that I've labeled. So the X value would be x2. The X value is along the x-axis. The Y value will be the same as this point to the left of it in blue. So the y value will be y1. Now let's go ahead and talk about this distance I was talking about. From the yellow point to the blue point above it, since we're not going left or right, we know exactly how far apart those points would be. Those points would be y2 minus y1, whatever that changes. So remember, y2 is a number, y1 is a number. The length of this side, the leg of the right triangle, is simply y2 minus y1. Now if your y1 is greater than your y2, then it would be y1 minus y2. So to fix that, we often use absolute values to just denote the distance between two numbers. So if I throw absolute values around that, then your triangle is going to have the exact same height as my triangle. And pause the video if you need a minute to think about that. Okay, once you feel comfortable with that idea, I'm going to label this other leg of the right triangle, the base here in my picture, and you'll notice that this distance would simply be, so to walk this distance I would simply be walking a horizontal line. I don't move vertically whatsoever, so that distance is quite obvious. It's simply the difference between my x values. Now here x2 is greater than x1, so I'm going to write x2 minus x1, but perhaps your x1 is greater, so again we'll throw absolute value bars around that. Those absolute value bars will always simply find the distance between x2 and x1. And that's why I ask you to pause the video. That is something that's difficult, and it's okay for you to take a minute and think about that. It's difficult to understand, but absolute value bars just find the distance, the positive distance between two values. Once we have all of this labeled, then I want you to think about how would we find the length of the hypotenuse. I have d here for distance. And you might recall the Pythagorean theorem. The Pythagorean theorem says for any right triangle, the sum of the squares of the legs, so a squared plus b squared, is equal to the hypotenuse squared, often c squared. A squared plus b squared equals c squared. Most even adults remember that from a geometry class. Well, you'll notice we have a right triangle here. A squared so this is the length of a squared plus b squared equals the hypotenuse squared. That is simply the Pythagorean theorem. A squared plus b squared equals c squared. Now, absolute value bars are already positive, so when I take an absolute value and I square that, it really has no effect on the value whatsoever. So this is the same as writing x sub 2 minus x sub 1 squared, quantity squared, plus y2 minus y1 quantity squared is equal to d squared. I hope you have this question right now. Well, what if I had x1 minus x2 in my absolute values? Again, it wouldn't matter. Think about whenever you square a negative number, so negative 4 times negative 4 is positive 16. It will always simply find that positive square. So this order inside does not matter. Why am I discussing that? You won't believe how common it is as a teacher to get the question, well, what's the order for the distance formula? And hopefully after this exercise you realize that order does not matter. It doesn't even matter if I write this yellow term before the red term here, the yellow term before the red term. Because of the commutative property and addition here, that wouldn't change that either. So what you'll notice that we have here is the distance is equal to, and if you were to take the square root of both sides, we only care about the positive square root, because we're trying to find distance. So this would be the principal square root, and we get the distance formula here. Now, hopefully, if you spend some time walking through this, I would encourage you to practice it again. You will realize that order does not matter inside the parentheses, and also you could have found the difference in the y values before you found the difference in the x values. So I wholeheartedly believe that this is a really good exercise to practice. Make sure you're familiar with it. Students are often asking me, what's the distance formula? And I guarantee it shows up on standardized tests. So it's very important to remember it. Try to practice this. You just worked the distance formula.